Hello everyone, welcome to Logic App tutorial. In this video, we'll see the differences between application service environment and integration service environment from the consumption based and standard Logic App perspective. What is the reason the Microsoft came up with the ASC? So, what are the differences between these two plans? So, it is in continuation with our previous video. If you have not watched the previous video, just watch it first so that you will get the more clear knowledge about this. Okay, so let's directly jump into that. So, if you know, earlier we had a ISE integration service environment. So, the one benefits of using the ASE versus ISE is portability. Okay, in ISE, what happened is we need to develop the logic app against the existing resource present in Azure portal. What it means I have created one consumption based logic app. This is one of the consumption based logic app. If you see, so now if you go to this designer, so if you want to change anything into this logic app, you the what you need to do is you need to do against this only, right? Either you change into this Azure portal, or what you can do is you can open up the Visual Studio, and then you can download this logic app player. If you have worked earlier with this Visual Studio and working along with this consumption based logic app, you must be familiar about this. If not, just let me know, I'll create one and I can quickly show that as well. So in that, what we used to do is we need to create it either from the portal, Azure portal. We can add steps or anything, or we need to download this in the Visual Studio, and there we can do these changes whatever we want to do. So it means we need to do the logic app development against the existing resource, right? Now with the ASE, we can develop the logic app in local, or using the Visual Studio code. We can build there and we can run there, and then we can deploy it into the ASE environment and we can test it. What it means with Visual Studio code, and we'll see that in our upcoming videos. We'll create one standard logic app. This is the standard logic app. So we'll create one standard logic app, and then we'll create multiple workflows using the Visual Studio code. And with Visual Studio code, we can not only develop them in our local system, but what we can do is we can build them and we can run them also. We can test them also locally, even if it gets deployed to portal, right? So this is the one of the benefits. Now second is deployment. So in case of ISE, if you remember, we used to deploy using the ARM templates. What we do is we go and we create the one of the logic app over here or from Visual Studio, and then we generate the ARM templates. We need to give the production parameter file, dev parameter file, UAT parameter file, right? And then we associated that ARM template, and then we create a DevOps pipeline or something, and then we deploy it. But what happened there is, so for example, this is one of the consumption based logic app, and if you see the code view, right? So in this code view, we need to take care of the resources which are associated with this. For example, if you see this create blob action, and here if you see the connection, so this is the connection ID it is taking. So now if we come down, right, at the bottom, you see this is the connection ID we are taking, and there are the resources, right? So there is an option called resource also comes into along with this one. So we need to take care of other resource deployment also. It means we combine the other necessary infrastructure and the logic app code, okay, to deploy it using the ARM template. So if I just see here export template, you see here there are different resources options is also available, right? And this the parameters come directly, and this is the one of the resource logic app workflows, right? So if there are some other resource also tagged with this one, then we need to combine those all of them into the same ARM template. It cannot just have the logic app code or workflow code in our ARM template. We need to combine all the other resources, means all the infrastructure and code should be combined in the same ARM template. Okay, so this is what this was happened when we used to have the IC based logic apps. But now with ASE, what we can do is we can separate the app deployment from the infrastructure deployment. We can zip package for the deployment of app infrastructure can be deployed using the ARM separately. What it means? It means the AC based logic app deployment. If you see here, so first of all, one logic app can have multiple workflows. So what we can do is, and we'll see that in action also when we create the standard logic app using the Visual Studio Code. So what we can do there is we can just zip all of them, and then we can just publish it and we can deploy it in one of the service, like how we do the deployment of any REST APIs, how we deploy it in web app, or how we deploy the Azure functions. Okay, so there we need to focus only on the code, not the infrastructure. So if you see this one of the standard logic app, and if you see the code view, so it uses one of the, it's a simple one, it is just the trigger based. So let it open, or we'll see the designer. Okay, it's just a recurrence based compose, so you will not get more things here. But I have created one standard logic app where I used one create blob action. So if you see this kind of work, this is the workflows, right? So you will see this kind of infrastructure of that code of the workflow inside this standard logic app. So here if you see in this create blob, we have one reference, right, for this API connection. So these things are get stored in this connection.json, and we don't need to uh, deploy the other necessary resources along with this code, along with the code of workflow. We can deploy the other necessary infrastructure separately using the other ARM template. Okay, so this is the one of the difference. Now performance wise, if you see in the ISA, we used to use the managed connectors. So what is the managed connectors? Managed connectors means we are using the connector which are using the managed API connection. Managed API connection means this API connections are managed by the Azure environment. We don't have control, like where that process is running to link our logic app with, let's say, one blob storage. When we call any blob storage, or when we create any blob, or we get a list of blob, so we need to create one API connection in any of the logic app, whether it's AC based or IC, right? So that managed API connection is managed by the Azure. It can run anywhere, right? Hence what happened is, and that runs outside of the scope of that logic app, or let's say of that IC, even of that IC. So what happened is, it can come in the ISE, but the ultimately that runs outside of the scope of the logic app, right? So that degrade the performance. It needs to talk to one process, needs to talk to other process, right? And API connection needs to deploy separately before the logic app. We must have that API connection should be there. Otherwise, we cannot, connect that logic app with particular resources. For example, if you see here, so this is the consumption based logic app, right? And in this logic app, we have this create blob action. Okay, so in this create blob action, I have used this API connection. Now if you come to this API connection, this is the API connection. If you go to this API connection, there is a separate resource named as API connection. If you search here API connection, so this is a separate resource. For example, logic app is separate resource, storage is a separate resource. So this API connection is a separate resource, so it has its own runtime, and it uses its other compute and storage other than the logic app. So this logic app, this consumption logic app, needs to talk to that API connection. So that's where the performance gets degraded. When we come to ASE, it provides a lot of built-in connectors apart from the managed connector. So built-in connector provides significant performance improvement as compared to managed connectors. How? So if you see this logic app, so here we don't have any of the connector, we did not use, because these are the inbuilt actions. So if I go here and if I see here, right, so I will get the three runtime options here. One is in-app, one is shared, and one is custom. So what is in-app? In-app means it is a built-in connector. Built-in connector means it is not like the API connection which we have seen in case of consumption based logic app. So this connector resides in the memory, in the same memory where we have this standard logic app. So all the workflows inside this one standard logic app will share that same built-in connector. So this workflows need not to go to other VM or other process to talk to that any resources which is associated with built-in connector. Okay, so this we call as a built-in connector. And the other option which we have seen, there is a shared. So shared means it is same like API, like managed connector. So we can here also we can use the shared as well. Okay, so we can use both in this case, because built-in operations and connections run locally. So as I mentioned, the built-in operations and connections that run locally in the same process where workflow runs. So that's where these connections get deployed in the same package of the app. And also what we when we deploy this logic app workflows, standard logic app workflows, so in the same package when we zip them, then these connections also get deployed. So we no need to deploy them separately, like how we used to do in the consumption based logic app. Okay, so now next is resource sharing. So when we used to create the ISE based logic apps, so logic apps in the same environment share the same processing like storage, network, and so on. What it means if we have one integration service environment, and let's say there are thousands of logic apps, so all those logic apps will share the same processing and compute units. Okay, whereas in AAC based logic app, all the workflows in a single logic app and tenant share the same processing unit. We see like this. For example, this is the consumption based logic app. So if let's say I have created thousands of such kind of consumption based logic apps, so they all will share the same processing unit in compute of that integration service environment. Okay, so there can be performance degrade over there, right? Because all are looking for the same memory and same compute CPU, right? Whereas in standard logic app, it drills down further. How it drills down further is the workflows inside this standard logic app will share the same processing unit, same memory. But if let's say I created the another standard logic app, even within the same application service environment, so that logic app will have the different processing and different computes. Okay, so all the workflows inside this standard logic app will not share any resources with the other standard logic app. So this way the performance gets improved. Okay, so this is also one of the resource sharing concept and benefits. Now workflows, as we have read a lot of time in ISE, we can create one logic app per one workflow, but in ISE we can have many workflows. And pricing, so ISE we need to pay based on the ISE, but in ASE we pay based on the selected app service plan. So these are the basic, or you can say overview kind of thing. So when we go further into this, then we will see a lot of other differences also in practically. But for today I think this is enough, so we'll meet soon in our next video. Thank you for watching.